Up north, beyond the edge of the world we see, an entire kingdom of ice is dying. Not slowly, not gracefully, but in a state of terminal collapse. More than 120 trillion metric tons of Greenland's ice sheet is already gone. Not gone in the sense that it has melted, but gone in the sense that it has been sentenced to death. This is the part of the story you have not been told. This is not a warning about future emissions. This is not a projection of what might happen. It is a diagnosis of what has already occurred. This ice is no longer being replenished by its parent glaciers. It has been cut off. It is now floating, breaking apart, and committed to melting into the ocean, regardless of what humanity does next. It is, in the stark language of glaciologists, zombie ice. On August 29, 2022, a study published in the journal Nature Climate Change delivered the final verdict. Dr. Jason Box and Dr. William Colgan, two glaciologists at the Geological Survey of Denmark and Greenland, or GEUS, presented the findings. They calculated that a minimum of 3.3% of the Greenland ice sheet's total volume is now in a state of disequilibrium. It is, in Dr. Box's words, ice with one foot in the grave. It's just going to melt and disappear. This ice has been consigned to the ocean. That 3.3% might sound small. It is not. It equates to an unavoidable locked-in global sea level rise of at least 27 centimeters. That's nearly a foot. And that is their most conservative estimate. The number could be as high as 78 centimeters, or over 2.5 feet. Let me be clear about what this means. 27 centimeters of sea level rise is no longer a possibility that we can fight to prevent. It is a consequence that is already on its way. The only variable now is time. But here is the detail that tells the real story. For two cities on Canada's east coast, that rising water is only half the problem. As the ocean rises to meet them, the very ground beneath their feet is sinking to meet the ocean. To understand what is happening to Halifax, Nova Scotia, and St. John's, Newfoundland, you have to understand a ghost. A ghost made of ice, 2 miles thick, that disappeared 10,000 years ago. That ghost was the Laurentide Ice Sheet, a colossal glacier that covered most of Canada. Its immense weight pressed down on the center of the continent, near what is now Hudson Bay, causing the Earth's mantle to squish outwards. This forced the edges of the continent, the land of the Maritimes, to bulge upwards like the ends of a squeezed mattress. For millennia, while the middle of Canada was crushed under ice, the east coast was propped up high. Then, the ice melted, the great weight was lifted, the center of the continent began to rebound upwards, and that geologic teeter-totter began to tilt back. The land that was once bulging up, Atlantic Canada, started its long, slow descent. It is still sinking today. This process is called glacial isostatic adjustment. It is a geologic hangover from the last ice age. And it is the curse that defines the future of Canada's east coast. I'm actually curious what you think about this. Let me know in the comments if you've ever heard of this geographic curse before. The data is precise. The land in the Maritimes is subsiding at a rate of approximately 15 centimeters every century. It does not sound like much, but you have to combine it with the water coming from the other direction. Throughout the 20th century, Halifax experienced a relative sea level rise of 3.3 millimeters per year. That is more than double the global average of the time. The city isn't just facing a rising ocean, it's fighting a battle on a sinking foundation. Dr. Patricia Manuel, a professor at Dalhousie University's School of Planning, has spent her career studying this. In her words, the tidal zone is moving landward. Areas where the tide had not previously reached are now being inundated. It is not a metaphor. The land is falling as the sea is climbing. This is the double blow, one delivered by a melting present, the other by a frozen past. Now, here is the part the headlines do not capture when they talk about cities disappearing. The threat is not a single cinematic tidal wave that swallows a city whole, Atlantis style. It is far more insidious. It is about the slow, relentless elevation of the baseline. It is about the redefinition of what constitutes a normal storm. For 2 decades, Tim Webster, a geomatics researcher at Nova Scotia Community College, has been creating a grim map of the future. Using high-resolution LiDAR scans, he has mapped the exact flood risks for downtown Halifax. His models show what happens when the slow creep of sea level rise meets the sudden violence of a storm surge. The benchmark for disaster in Halifax is Hurricane Juan. In September 2003, Juan made landfall as a Category 2 storm. It pushed a 1.5-meter storm surge into Halifax Harbor, causing over $300 million in damage. It flooded the historic waterfront, swamped the container terminal, and turned low-lying streets into canals. For years, Juan was considered the once-in-a-century event. It is now the blueprint for a normal Tuesday. By the year 2050, Halifax is projected to experience a relative sea level increase of another 40 centimeters. 40 centimeters is the new floor. It means that a routine winter nor'easter, a storm that happens multiple times every year, will have the power to push the same volume of water into downtown Halifax that the Category 2 hurricane did in 2003. The water that once required a 100-year storm will soon be delivered by a seasonal squall. Extreme water events that historically struck once every 50 years are now projected to occur more than once every 5 years. The city's critical infrastructure lies in the path of this new reality. Lower Water Street, the vibrant heart of the city's tourist district, will be chronically flooded. The Armdale Roundabout, a major traffic artery, will become impassable during high tides and minor storms. At Tufts Cove in Dartmouth, across the harbor, critical power infrastructure sits just meters above the current high tide mark. The Halifax Regional Municipality officially declared a climate emergency on January 29, 2019, creating an action plan called Halifax 2050. But the plan is an attempt to adapt to a reality that is accelerating faster than any model predicted just a few years ago. Halifax Water, the city's utility, is already redesigning its stormwater systems, not just to handle rain from above, but to stop the ocean from pushing up through the drains from below. And 800 kilometers to the northeast, the story repeats itself, but with a different accent. St. John's, Newfoundland, the oldest city in North America, faces its own unique combination of threats. While it also contends with the sinking land and rising sea, its primary vulnerability is water from the sky. Climate models for St. John's are stark. By 2050, the city projects a 28% increase in precipitation. Extreme rainfall events will become more frequent, more intense, overwhelming an aging infrastructure built for a 20th century climate. The city is a bowl, surrounded by hills, funneling that water down towards its harbor. And at the bottom of that bowl, the ocean is waiting. Projections for St. John's see a local sea level rise of 75 to 100 centimeters by the end of the century. That's up to a full meter, 1 meter higher, with 28% more rain falling from the sky. This is how a city's waterfront, its economic engine, and its historic soul becomes uninsurable, then unusable, then abandoned. Not because the entire city is underwater, but because its most vital components are. We go to great lengths to uncover these interconnected stories that often fly under the radar. If you find this kind of deep dive valuable, you can subscribe for more. It helps us continue to make them. Now, zoom out from the sinking coastlines of Canada, past the zombie ice of Greenland, and look at the entire North Atlantic Ocean. The greatest threat is not the water you can see. It is the disruption of a current you cannot. The massive, unprecedented influx of cold, fresh meltwater from Greenland is actively poisoning the engine of the planet's climate. It is called the Atlantic Meridional Overturning Circulation, or AMOC. It is one of the most powerful current systems on Earth. It works like a planetary conveyor belt. Warm, salty water flows north from the tropics, releasing heat into the atmosphere and warming Western Europe. As it reaches the area south of Greenland, in the North Atlantic subpolar gyre, it cools, becomes denser, and sinks deep into the ocean. This sinking water then flows south, driving the entire global circulation. For thousands of years, this engine has been stable. Now, it is sputtering. The 120 trillion tons of doomed Greenland ice and the hundreds of gigatons melting alongside it every year are pouring fresh, buoyant water directly into the spot where the ocean is supposed to sink. Fresh water is less dense than salt water. It will not sink. It sits on the surface like a lid, choking the engine, slowing the entire conveyor belt down. Dr. Stefan Rahmstorff, a climatologist at the Potsdam Institute for Climate Impact Research, is one of the world's leading authorities on the AMOC. His work, and the work of many others, shows the current is now at its weakest point in over 1,000 years. And what happens if it collapses entirely is a global paradox. A shutdown of the AMOC would not warm the world uniformly. It would trigger bizarre and catastrophic regional shifts. Without the warm water flowing north, Europe could be plunged into a period of severe cooling. With brutal winters becoming the norm, meanwhile, the water that used to be pulled northward would pile up along the east coast of North America. An AMOC collapse could trigger an additional, rapid sea level surge of up to a meter for cities like Halifax, Boston, and New York, on top of the rise already baked in from melting ice. It is the ultimate climate irony. The melting of Greenland's ice could lead to freezing conditions in London while simultaneously unleashing devastating floods in Halifax. That is a lot to take in. If you find this kind of information helpful to understand our world, maybe consider sharing this. Getting the word out really helps. A project led by the British Antarctic Survey, codenamed Giant, is now racing to understand this tipping point. Their research is confirming what many scientists now fear. Now, here is the part nobody is putting on the news. For years, the Intergovernmental Panel on Climate Change, the UN's climate body, considered a collapse of the AMOC a low probability post-2100. Their models were conservative. Their timelines were long. But the new data from Greenland has shattered that consensus. The sheer volume of freshwater entering the North Atlantic is so extreme, and the weakening of the current so rapid, that the scientific consensus is shifting dramatically. The tipping point is no longer a distant 22nd century problem. New models suggest a severe slowdown or even a full collapse could be possible before 2050. Within the lifetimes of most people watching this is the largest scale of the threat. It begins with a specific physical process, the disequilibrium of the Greenland Ice Sheet. It manifests as a localized geologic trap, the sinking of the Canadian Maritimes. It creates a chronic existential threat for coastal cities like Halifax and St. John's by changing the very definition of a storm. And it feeds into a planetary-scale disruption that could rewire the climate of the entire northern hemisphere. Each layer of the problem is happening at the same time. Before a city's downtown floods, the first sign of the invasion is something quieter. Along the coasts of Nova Scotia and New Brunswick, ghost forests are beginning to appear. These are whole groves of dead, bone-white trees standing in salt marshes where they once thrived. As the tidal zone moves landward, as Dr. Manuel described, salt water infiltrates the soil, poisoning the roots of terrestrial plants that cannot tolerate it. The trees die. Their skeletons remain, bleached by the sun. It is a silent, eerie indicator of the saltwater front line. The land itself is becoming toxic to the life it once supported. These ghost forests are the canaries in the coal mine for the harbors and homes just a few feet higher in elevation. So what is actually being done? In Halifax, the Halifax 2050 plan is a comprehensive strategy that aims for carbon neutrality and climate resilience. It involves everything from retrofitting buildings and electrifying the bus fleet to, crucially, protecting and restoring natural coastal ecosystems like salt marshes, which act as natural buffers against storm surges. But these are defensive measures against an invading force that is constantly gaining strength. Engineers can build seawalls higher, but it's difficult to do on a foundation that is actively sinking. The city is planning for a future that is arriving ahead of schedule. The problem with planning for a 2050 scenario is that the 2050 scenario, according to the newest data, may arrive in 2040 or 2035. The acceleration is the variable that no one can precisely model. The Intergovernmental Panel on Climate Change previously estimated Greenland would contribute a relatively modest 6 to 13 centimeters to sea level rise by 2100, so 2022. Zombie Ice study proved, with observational data, not models, that more than double that amount is already guaranteed. The IPCC's reports are consensus documents, built over years, and are often out of date the moment they are published. The reality on the ice is moving much faster. A separate simulation study identified another tipping point. At a sustained warming level of plus 3.4 degrees Kelvin, Greenland would be locked into a complete deglaciation that would trigger a sea level rise of 7.4 meters, 24 feet. That is the ultimate endpoint if the process is not halted. And the 120 trillion tons of zombie ice are the first irreversible step on that path. The human element of this is often lost in the gigatons and centimeters. For St. John's, a projected 4.8 degrees Celsius increase in daily average temperatures by the 2080 S doesn't just mean warmer summers. It means a complete change in the regional ecosystem, the fisheries, and the very culture that has defined Newfoundland for centuries. When the cod fishery collapsed in the 1990s, it was an economic and social cataclysm. The climate-driven collapse will be slower, but far more comprehensive. It isn't just one species that's threatened. It is the physical stage on which life in the Maritimes is lived. There is a tendency to view these events as distinct. A glacier in Greenland, the geology of Nova Scotia, a current in the Atlantic. But they are not separate stories. They are one story. The heat trapped by our atmosphere is not just warming the air. It's a colossal energy surplus that has been absorbed by the ocean. That energized ocean is now attacking the ice sheets from below, melting them at their bases, that melt water. In turn, disrupts the ocean's circulation, which then alters the path of storms that deliver rainfall and storm surges to the coastlines. It is one single interconnected machine. And we are seeing, for the first time, multiple gears in that machine beginning to fail simultaneously. The question in the title of this video is, will Halifax and St. John's disappear by 2050? The literal answer is no. But their historic waterfronts, their economic hearts, their cultural touchstones that sit by the water's edge, they will be lost. They may be protected by massive expensive walls for a time, becoming fortresses against the sea. Or they will be abandoned to the new higher tide. The cities will survive, but they will be fundamentally and permanently wounded. For now, the math is unrelenting. That 27-centimeter rise from the zombie ice is the absolute, non-negotiable floor. On top of that, you add the continued melting from the rest of Greenland and Antarctica. On top of that, for the east coast of Canada, you add the 15 centimeters per century of sinking land. And potentially, on top of all of that, you add the sudden surge from a collapsing AMOC.